So welcome everyone. Thank you for attending today's streaming. Our session today is to talk about how the Liquid Galaxy project is implementing the artificial intelligence paradigm in the project. So since years ago, we started to use, of course, different machine learning and systems around artificial intelligence. Of course, we usually try to stay on the Google ecosystem using TensorFlow and so on. And sometimes contributors go to other technologies. For this year, 2023, we think about to have a special server, a local server in our Liquid Galaxy rigs, where our cluster of machines usually running Linux are held. And then for this reason, our beloved Google developer expert Mario Ezquerro is with us today. Hello, Mario.
Hello, everyone. How are you?
Not bad. Thank you for coming today with us, and congratulations on having your Google Developer Expert Award finally.
Thanks. This is a grand, event for me.
Okay, I think someone is sending me WhatsApps, and I didn't silent it. No, it's silent. So thank you, Mario. And the question is that we have built a few pieces of technology for the contributors to develop their projects, and I want you to explain. So first of all, what flavor of Linux we choose to run this, and what's the reason for?
Yeah, this year is the first computer for this project. Is not in cloud; it's on premise, and it's a special machine with an Intel boot. It has 2 hard disks, and the flavor of Linux I select for the first host running in the boot of the machine. He has a Rocky Linux because he's a family or Red Hat. The reason is because it's a typical who using technicals and high-level projects is usually use the families which is based in Red Hat systems. The work which use open source is usually save all his life more Debian, but for to Planet with this display or which used in cooperative
Environments.
Thanks. Is better this option. This reason because we pass to Rocky CentOS, but no for Rocky Linux and not CentOS because CentOS now is finished with for make new deployments with Linux. This is no good notice, but actually.
Yeah. Okay. Always the different. I say flavors of distributions of Linux have been always fighting, changing, and so on. This is Linux. This is the happy thing about Linux. So the important is that the distro you choose was Rocky Linux, and it's the de facto standard, I will say, on the actual enterprise when you go to the cloud. Is that correct?
Yeah, when the CentOS finish, they have 2 flavors of Linux, which is Fleet, sorry, which is Rocky and Alma Linux. And the cloud systems all select Rocky Linux. You can find or you can eat in Google Cloud, Azure, and AWS. You can select in the based systems Rocky and not Alma, because this is a good reason, because the best opportunity for work in the industry actually is, I think, is Rocky.
And also you mentioned another very important question is that this service is not on the cloud, and let me explain why.
Yeah.
The reason is simple. It's because usually we don't have budget for cloud services, because the applications that contributors develop are open source, and those are not real projects that are going to be running on the real world, not too much. So if someone takes this project and wants to run it for real, maybe this person or company will have their own server out the cloud. But for us, it's cheaper to have our own machine in our own land and then run it without having to pay Google Cloud, or so on. So that's the reason. So the other question, and I see you have a very nice shirt today, is that what is the technology used behind the Rocky Linux?
The second question is very important because over the Rocky Linux is installed Docker. Docker is the first solution for containers. And this is also because if you work in on-premise, when you use a simple registry, this is a database for the containers. You can pass on-premise to cloud when two commands, Docker push and Docker and Docker run, for example. It's very easy, and this is reason because you can testing inside when special security on premise when you use containers, and then you when you finish the work with people of developers with this project on Liquid Galaxy, you can pass to the no work to cloud, and then this is why this is very easy, I suppose. Or for me, it's very easy.
Yeah, of course, but you're an expert now. So the point is that the students, contributors will have at their own home the instance running in whatever virtual machine or maybe even a physical server, and then they have to create this Docker image. Is the name the Docker image?
Okay, it's more easy because he has created a Docker file with it explain what image you can use, and then the second command is the code which is making Hashlators, and we say a Docker build. It's a simple command which pass this commands to run in on-site his laptops, and when it start and he said all is working fine, it push to this server to create and testing this project, and it's very easy to translate from his platforms in her house and his laptops to the server, and this is a good idea for the ubiquitous. Ubiquitous is capacity to translate with when the word or the sentence in my house working, and this is reason because I have recommended use containers because in my house worker and the server work too.
Yeah, you can move the Docker because it's the standard. All the industry uses Docker, yes. So then if you have the image in somewhere, you can move it to another place and run it in the same way. That's nice. Very good. So thank you, Mario, for today's introduction. I only have to say that we have this year 4 different projects that use artificial intelligence. Let me try to remember those ones. It's the one that makes run the Galaxy with gestures with your hands and your arms and so on. We have another one that is using different APIs for creating artificial voice, and also to find the location of the camera at the Liquid Galaxy and try to think what are the surroundings of the place. Something like if you are in Paris, it will call an API, external API, and say what are the things I can visit there or whatever. Then we have another one that is called Satellite Collision, that a student is creating their own model, and the model tries to getting information from the database from the American government. The student is gonna predict if a satellite will crash in the future. And last but not least is the Liquid Galaxy iArt, next to our mentor Victor, also Google developer expert, that is creating some kind of artificial intelligence art across the screens of the Liquid Galaxy using Midjourney, I believe. And I didn't mention that also on the board we have our beloved Moises Martinez, also Google developer expert, that is helping the other projects to run. So we are going to see in the next minutes a few demos of or at least explanation from the different contributors on what are their projects and what is the status for today. So again, thank you, Mario. Congratulations on being a GDE. And see you next time. We need your help.
See you later.
Thank you. Bye-bye.
Hello. My project this year is Satellite Space Collision Prevision. And this project is been developing with Kotlin, Python and JavaScript. Kotlin for the application, Python to treat the data and create the model with TensorFlow and Keras, and the JavaScript to create the API to connect the server to the application. The API will connect the application and the server to make a call to the model that will be hosted in the server. The application will predict the probability of two satellites to collide, and then will show in the Liquid Galaxy the position of the satellites, the orbit, and the area affected in the Earth. To create the model, I had to get the data and treat it. This process is going on two Google Colabs. This Google Colab is for the non-collision data. That I take all the values in a CSV like this, and then I treat it, and I created the positions here of the satellites for each hour. And then in the other Google Colab, I'm treating the data that is the past collision satellites. Well, I'm extracting the data from this PDF that I convert to XML to get the information I need. And when I get the model, this model will be I will create a Docker container with the API and the model, and then I will migrate the model to the server, local server. This is the server with Rocky Linux and the Docker installer with no image.
Hello everyone, my name is Shudhamna Chatterjee and I'm a GSoC 23 contributor for Liquid Galaxy. I'm working on the LG gesture and voice control project, which aims to add gesture and voice control capabilities to the Liquid Galaxy rig. So when I say gesture control, it means hand and pose control. So in order to add hand and pose control to the Liquid Galaxy rig, I need artificial intelligence, that is AI. In order to do that, first I need an API, that is a machine learning framework, for which I am using MLKit, which is an open source API from Google, which would allow me to add machine learning capabilities to my application, and that is to train the AI for hand and gesture recognition. Then I'll be using two models, which are MediaPipe hands and MediaPipe poses, respectively, for both hand and pose recognition. Both of them are open source AI models which have been already pre-trained and allow hand and gesture recognition. I'll be using both of them alongside MLKit to train a model which would then use the app's camera as well as voice speaker mics to take input from the user, that is to recognize hands, gestures, and then convert it all into KML and send it to the LG rig via SSH codes. So that is how I'm using AI in my project right now. Also, recently Google released their game face software which uses facial recognition. So facial recognition also requires AI, and I am currently making research on how I can add facial recognition as well into my project. Even though this will be a separate menu, but this should allow facial recognition capabilities to the LG rig, that is, I can control the entirety of it using my facial recognition. So yeah, that would also be then converted to KML and sent to the LG rig to communicate with their servers. Thank you, and that's it.
Hello everyone, how are you? My name is Vedant Singh and my project is Located Voice CMS, which deals with adding the voice, sound and AI context sensing functionality to the current Liquid Galaxy controller on the Play Store. So in my project there are two uses of AI. The first one is for text to speech. So for that I will be using Bark by Suno.ai, and I will be using it through a Flask API in a Docker which is stored in the LiDAR lab. And the second use of AI in our project is for context sensing. So the model for context sensing is not decided yet, but I will show you how it works. So as you can see on the screen, this is the Liquid Galaxy rig, and this is our the interface of our application. So by context sensing, we basically mean that wherever the Liquid Galaxy rig is pointing, we are able to sense the context and generate data according to it, like generating nearby places. So in the application, if we click on nearby places, when the Liquid Galaxy rig is pointing at a place, for in our example Alhambra Palace, so what will happen is the location which the Liquid Galaxy rig is pointing at, many nearby places will be generated and displayed in a balloon in the Liquid Galaxy rig, which we will be able to toggle with through our application. So this is about it. Yes, thank you.
Hello, my name is Murilo, and today I will talk a little about my project with the Art AI. In my project, we are using several image generation AIs, like DALL-E and Stable Diffusion, for example, of ones. We already have integrated Stable Diffusion and DALL-E API. The Stable Diffusion is going to have a local API run by Andreu. I plan to use the built-in feature of the Automatic 1111. That's a model that can build images that become very famous because it's open source, and we'll be using that and doctorizing it. So when they use the image on the Lieda computer, we could have a running API that could be used as a server.
Hi everyone, my name is Víctor Sánchez and I'm a Google developer expert in web technologies. One more year, I am spending a part of my summer collaborating with the Google Summer of Code, where students, mentors, and very interesting projects join together to produce high quality open source, hopefully. I am collaborating inside the Google Summer of Code with Liquid Galaxy. This is a project based out of Lleida and led by my friend Andreu Ibáñez. This year, my student, Murilo Nogueira, is working on a project called the Liquid Art, which is really cool. We are using AI from Midjourney to Stable Diffusion and of course Google's models on the cloud now to generate beautiful art that we're going to be exposing in this very high resolution that is the Liquid Galaxy rig. I have to say this has to be one of the most interesting projects that we have done so far, even though it's relatively simple, right? You introduce the prompt, you select the models, a couple of options based on the resolution and the quality of the image that you want to generate, and you are able to showcase it directly in the Liquid Galaxy. In order for this to be possible, since some of these models needs to run on a GPU, we are adding this year a new machine to the rig of the Liquid Galaxy with a powerful GPU that will allow us to run even some of these models locally and kind of put together a much more interesting and compelling demo for the Liquid Galaxy itself. As you know, demos around the year for the Liquid Galaxy are plentiful, and what we want to do is put in the hands of the people that attends these demos a very interesting demo on how to generate and how these diffuser models actually work. A Stable Diffusion, Midjourney, and now Google are going to be kind of democratizing, right, the content creation that were before a very small group of people that was able to generate high quality images. And very soon, but by the way, these models are going to be able to do the same with voices, videos, or even 3D models. So we are about to see an explosion of content. From a project perspective, obviously the application and the networking part of it is going to be an interesting part, of course, for any student. And the other thing that is going to be extremely interesting is obviously in order to generate these high quality images that are required to be shown on a high resolution screen as the Liquid Galaxy is. It will require probably some addition and some kind of remodeling or readjusting on some of these generative models, which is going to be as well a pretty challenging task, I'm sure, but one that our students are absolutely up to doing it. I will continue to report on the advancements on the projects. In the meantime, have a nice Google Summer of Code.